Hello, and welcome to part 2 of our feed-forward conditioning special, hosted by Triot companies PTN, Almex and IVS. It's called the Guide to Great Conditioning, and as the title suggests, we're going to take you through the entire process, help you unlock greater value from conditioning, and ultimately produce the highest quality product at the optimum price and capacity. Our experts, Ronald Tenkate of PTN and Robert Veenendaal of Almex, will explain what conditioning is. They'll outline the critical factors needed for success and how to balance these against your ultimate goals, from pellet quality and pellet press productivity to optimal nutrition and hygienization. Then we're going to take you on a unique step-by-step immersive walkthrough of how all this translates into different conditioning technologies and setups, from single, double and triple conditioners to the hot start conditioner, to the retention time barrel, to the boa compactor and the expander. This also includes a brief recap on the importance of steam with Frank Deelerson of IVS, who covered this topic in detail in part 1 of this conditioning special. If you missed it, don't worry, it's still available on the Triot website. Added to this, we also get invaluable outside-in perspective from Mr. Philip Rowold from the Agravis Group, a leading customer of PTN, Almex and IVS. Finally, we'll take a brief look at the future and the potential for you to work with Triot and third-party R&D experts by putting conditioning to the test, literally. It's another packed show, so let's get started and join Lars and our conditioning crew for the Guide to Great Conditioning.
Hello everyone, and thanks for joining us for this Guide to Great Conditioning. Today we're going to talk and walk you through the whole thing, kicking off with our resident experts, Ronald Tenkate, Area Sales Manager for PTN, and Robert Veenendaal, Global Sales Manager for Almex. The obvious question is, of course, what is conditioning?
Conditioning is the process of producing a mash feed dosed with liquids, steam, water, oil or molasses to produce a homogeneous product before pelleting.
Right, now in the first part of this special we talked about 4 key parameters for this process. So let me see if I've got this correct. We need temperature created by overheated dry steam, moisture content created by either steam or water. Both need to be dosed correctly. Thirdly, the retention time, a machine that has the optimal dimensions for the capacity needed. And finally, mechanical friction, the amount of shear and pressure on the product.
Correct. In our previous episode, Frank Deelerson from IVS already explained everything about temperature and steam.
Indeed, he said that if you put poor quality steam into a conditioner, you get a poor quality product out of it.
This is 100% correct. However, if you put great quality steam into a wrong conditioning setup, you still get poor pellet quality.
And to be clear, when you talk about pellet quality, what does that mean?
Proper conditioning of feed involves the converting of the mash with the use of heat, water, pressure and time to a physical state that enables the mash to be pelletized.
It's all about capacity, durability and the nutritional and hygienic quality of the pellets. But why does conditioning affect the hygienic quality?
Nowadays, it's getting more and more important to produce safe feed by creating enough temperature and retention time in your conditioning system. Salmonella and other bacteria will be eliminated.
And success in achieving these different goals are determined by the 4 factors we've just outlined and which we'll dive into in more detail, of course, later on.
Yes, it's not about producing the highest pellet quality possible. It's also about the optimum quality for the individual customer. For example, an integrator will often need a different quality than a commercial feed producer.
Okay, let me bring you in now, Robert Veenendaal. Welcome to the show. Now, there is no one-size-fits-all solution then?
Put simply, no. Every conditioning setup needs to be unique in order to produce a pelletized product that is tailored for the customer.
And what do you mean by that?
One day they may be producing a relatively straightforward formulation with no hygienization requirements.
I feel a but coming up.
Indeed, but the next day they may need to produce a hygienized feed which needs a high temperature and long retention time.
And of course there are many scenarios in between which we're about to tackle. Thank you for now, Robert and Ronald. But first, if you have a question about conditioning, please send it to us via the chat and our conditioning crew will get back to you. For now, let me be your guide as we walk you through the conditioning process. Right here, you can see why conditioning is such a big challenge. At first glance, these magnificent machines don't look so different, but each one is designed to perform very specific and different tasks. By the way, this is not the exact size, and in the feed mill, you'll find them on multiple separate floors. So let's find out when and why you should use them. As viewers of our recent Feed Forward episode on this topic will know, it all starts with steam. Many of the conditioning problems we see at customers are caused by poor steam quality, which is simply not hot enough or dry enough. It's therefore essential that you start with a correctly dimensioned and well-designed steam set connected to your conditioner to optimize both pellet quality and capacity. If you missed it, I urge you to watch part 1 of the conditioning special on steam, which you can find on the Triot website. Okay, now on to the conditioning setup itself, starting with a single one-shaft conditioner. If you're working with raw materials like corn, wheat or barley, which are high in starch content, you'll need a retention time of no more than 10 to 20 seconds, and temperatures no higher than 80 to 85 degrees Celsius. The key point to remember is that this system is not first in, first out. Even though you can get retention times of up to 40 to 60 seconds, this isn't enough for hygienization. For hygienization, in most cases, first in, first out is recommended, so a retention time barrel is needed. But we'll come to that shortly. Now, for this conditioning process, you might try to imagine what is actually happening inside the conditioner. So let's take a quick look inside the black box with Ronald. Ronald, I'm seeing what looks like paddles on a rotating shaft inside the conditioner. What influences the retention time?
Well, the retention time of a conditioner is influenced by 5 things. First one is the diameter. The bigger the diameter of the conditioner, the more volume the machine has, which results in a longer retention time. Secondly, the length. A longer conditioner also results in more volume and a longer retention time. The retention time depends also on the angle of the pedals. The shape of the pedals is important too. The less surface they have, the more filling degree can be created, which results in a longer retention time. And our last point is the rotation speed of the shaft. A lower shaft speed creates less transport in the conditioner, so the filling degree and retention time will increase. To change the speed of the shaft, a frequency controller is needed. By taking these points into account, we can help our customers to create an optimal conditioning system based on the type of feed, the capacity and the quality needed.
Okay, is there anything else we need to consider?
The retention time we need is also depending on the feed particle size. For liquids, it takes longer to penetrate the center of a large particle than a smaller particle. For this reason, coarse grinded feed requires a longer retention time than fine grinded feed.
Now, to double the retention time up to 40 seconds at the same temperature, a second conditioner can be added. You can even triple the retention time to 60 seconds by adding a third conditioner, again at the same temperature. For animal feed, dosing of steam and liquids takes place on the top conditioner only. Now, the sooner you add this, the more time it has to penetrate your feed. Now, if it's essential to have every kilogram feed heat treated from the beginning of each batch, you need a hot start conditioner. A regular conditioner and a hot start conditioner look the same, but once again, if we look inside, you can see how different they are. The feed is pushed through by pedals working in a backward direction until it reaches the desired temperature, and then the pedals push it forward. This guarantees the product temperature from the start of each run and minimizes any product loss. In fact, the hot start conditioner guarantees the preset temperature from the very first kilogram. After the hot start function, this machine is operating as a normal one-shaft conditioner. So, Ronald, what type of feed would the hot start conditioner typically be used for?
Mainly for poultry feed, but we believe it could become the standard for all products. Many customers need a guarantee that their feed is heat treated from the first kilogram. It's critical for the feed safety and to avoid salmonella and other bacteria.
Oh, and so that's why you've developed this new improved hot start conditioner model.
Yes, the feed milling industry is getting more and more interested in our hot start conditioner. It's more hygienic and there is no rest product left. Thanks to a frequency controller, you can empty the machine more efficiently.
It sounds like a really great option.
It is, but it's important to note that all conditioners we have covered so far do not have a first in, first out system.
What if you need first in, first out? And what if you require a retention time of 2 minutes or longer? In both cases, you need the retention time barrel, or RTB. The system can be preset to a guaranteed temperature and time of up to 85 to 90 degrees Celsius for 1 to 6 minutes. This depends on the application. The setup here is combined with a conditioner on top. It can be used for hygienizing your feed formulation in a pelleting line or in a mash feed line. Don't forget that hygienizing requires a temperature above 85 degrees Celsius and a minimum retention time of 3 to 4 minutes. So you must combine this system with the conditioner.
Yes, Lars. You first need the conditioner to heat up the product to the correct temperature.
And how exactly does your technology achieve first in, first out?
We achieve first in, first out using a special screw that pushes the feed continuously through the barrel. At the end of the shaft, a special dosing device takes care of a continuous flow to the next machine, like a pellet mill, expander or extruder.
Ideal for hygienization. Anything more to add?
Well, Lars, for a hygienization line, it is important to trace and insulate the equipment from the feeder till the cooler. This reduces condensation problems, and by doing this, you get less contamination and less cleaning is needed.
Finally, Robert, what about size?
Well, Lars, the size of the RTB depends on the capacity needed and the retention time. So it isn't a one-size-fits-all solution. In fact, we have 6 sizes available, based again on individual customer requirements.
What if heat treatment alone, whether short or long, isn't enough for your pelleting process? For example, if you're producing high-fiber cattle or horse feed that requires more mechanical shear to pre-compact the feed and make it easier to pelletize. If this is your challenge, PTN has created a unique 2-in-1 conditioning system called the BOA compactor. It can condition and pre-compact almost any feed type at temperatures up to 105 degrees Celsius. It compacts the recipe into a homogenized feed, which is easier for the pellet mill to handle, thus creating higher pellet quality. In fact, the machine itself is extremely compact, making it a good option if you have limited space available. First question, why is it called the BOA compactor?
We named it after the snake because it eats almost everything. That means you can use a wider range of raw materials to create high quality feed.
And where's the value of the BOA?
The more steam or liquids we add to the recipe, like molasses and oils, the higher the moisture content of the feed becomes, which can easily block the pellet mill.
And the BOA compactor can solve this by
Creating high mechanical friction on the feed. Due to the unique shearing action, the feed is pre-compacted and homogenized. It can be easily turned into high quality pellets without blocking the pellet mill.
so you can add more liquid.
Yes, for standard conditioning, you can only add liquids up to a maximum of 3 to 4%. By using a BOA compactor as a preconditioner, you can more than double this, up to 10%.
This is really a unique technology.
Yes, Lars, it is, and we are already working on the second generation. We now have a hot start BOA compactor running in a pilot project with one of our customers, which we are very excited about.
Exciting indeed, but not even the BOA can do it all, which is when you might need an expander. The expander is a pre-compacting technology, like the BOA, that enables you to use a wider range of raw materials, especially those that are usually difficult to pelletize with a standard pelleting line and a single one-shaft conditioner. What makes the Elmex expander unique is its ability to condition and hygienize feed at temperatures typically ranging from 110 to 130 degrees Celsius with more mechanical friction. The result? Increased gelatinization that helps the animal digest the feed better. And faster hygienization, otherwise known as high temperature, short time, or HTST. Why is this high temperature so significant?
It's all about gelatinization. The expander is the ultimate technology for binding particles in the feed. It changes the cell structure so that a higher quality product is created, which is more easily digestible for the animal.
And hygienization.
Yes, one way to kill salmonella and other bacteria without damaging all the vitamins inside the feed is to reduce the retention time. The expander achieves this with a high temperature and pressure in a short time.
When you say a quality product, you're not just talking about the pellets now, are you?
Indeed, it's possible to produce expandate with this technology without the need for pelleting. Instead, the crushed cake from the expander goes directly to an oversized cooler and crumbler.
Why might a farm need or want expandate?
Well, expandate can be used in a liquid feeding system for pigs. It can also be used for cattle fed with a mixture of grass silage as part of the total mix ratio, which prevents selective intake of the feed. In both cases, expandate can be more cost-effective than pellets.
Sounds like an attractive option. What practical points does the feed mill need to consider here?
Well, you need to establish if the feeding systems at the farms can handle expandate. And you need to be aware that the bulk density of expandate is lower than the density of pellets, which can affect transport costs.
To illustrate the value of preconditioning technologies like the BOA compactor and expander, let's take a quick look at these pie charts comparing feed pellets quality.
You can see that quality of feed undergoing conventional conditioning is 40% dependent on the formulation or raw materials. But for feed that has been treated with the BOA compactor or expander, that figure nearly halves to 25%.
Therefore, this is an ideal technology for feed mills working with different or inconsistent raw materials.
Yes, it is.
Well, we hope that this guide has helped you to size up which conditioning system is right for you. While we have addressed the basics, I'm sure that many of you will have questions about how all this relates to your own operations and customers. So please, send us your questions via the chat and our conditioning crew will get back to you. We are extremely grateful today to be joined by Mr. Philip Rowold of Agravis Group, a valued PTN, Almex and IVS customer. So, let's get started. Herr Rowold, herzlich willkommen. Bitte stellen Sie sich und Ihre Funktion bei Agravis vor.
Mein Name ist Philipp Rowold. Ich bin Produktionsleiter bei der Agravis Kraftfutterwerke Münsterland in Münster. Wir haben 2 Kraftfutterwerke in der Gesellschaft und produzieren ca. 770.000 Tonnen Mischfutter für Schwein, Geflügel, Rind, Pferd, Mineralfutter und ein bisschen Heimtier.
Was sind die wichtigsten Anforderungen Ihrer eigenen Kunden?
Für uns ist halt wichtig, bei jeder Lieferung eine gleichbleibende Qualität in den Stall zu bringen, damit wir halt die Tiere durch ihre Wachstumsphasen möglichst gut durchbringen. Sprich, keine großen Schwankungen in den Zusammensetzungen, sprich Inhaltsstoffe, Protein, Faser, Rohfett, dass wir dort einfach ein kontinuierliches Produkt haben, was fließfähig ist, sprich, was in den Fütterungsanlagen läuft, dass die Tiere immer versorgt sind und der Landwirt halt möglichst wenig Arbeit damit hat.
Was bedeutet das für den Pellet-Produktionsprozess?
Ja, gut 50% unserer Tonnage liefern wir als granuliertes oder pelletiertes Futter aus. Und die zweitgrößte Energiequelle, die wir dort verwenden, das ist der Dampf. Und der Dampf hat verschiedenste Aufgaben beim Pelletieren, das Material geschmeidiger zu machen, dadurch Blocking zu verhindern oder das Material zu hygienisieren. Und deshalb ist es sehr, sehr wichtige Rohware für uns, der Dampf. Ja, wir sehen das wie eine Rohware, der muss in Top-Qualität vorliegen, damit wir dann ein gutes Produkt auf der Pelletierung erzeugen können. Also ich würde sagen, Step 1 beim Pelletieren ist ein guter Dampf. Und dann erst die Presse oder Konditioneur oder was auch immer. Aber Step 1 ist ein guter Dampf. Der muss da sein.
Also fängt auch für Sie alles mit Dampf an. Und dann können Sie uns etwas über Ihre Konditionierungssysteme erzählen.
Wir verwenden klassisch die Kurzzeitkonditionierung, wo wir 20 bis 30 Sekunden Einwegzeit haben des Dampfes, hauptsächlich fürs Schweinefutter. Im Geflügelfutter setzen wir auf sogenannte Heißstartsysteme mit Langzeitkonditionierung bis zu 4 Minuten. Und im Rinder- und Pferdefutterbereich setzen wir auf Boas zum Vorkonditionieren. Haben da sehr gute Erfahrungen gemacht mit der Boa, ja. Unsere Erfahrungen sind mit der Boa, dass es halt eine sehr flexible Maschine ist. Also ich kann auf die verschiedensten Futtersorten, die wir heute haben, sehr viele kundenbezogene Mischungen, entsprechend reagieren. Dadurch, dass ich einen Spalt habe, der flexibel ist, von 0 nicht, von 2 bis 34 mm, kann ich halt entsprechend arbeiten. Was ich halt bei einer Doppelpresse, sprich einer Matrize nicht habe. Die ist sehr starr. Ich habe einen festen Presskanal, Durchmesser und Länge. Und da kann ich halt mit der Boa im Zusammenspiel mit Dampf und Flüssigkeiten halt entsprechend auf die verschiedenen Mischungen reagieren und eingehen. Daher haben wir da sehr gute Erfahrungen gemacht.
Sie verwenden auch Almex Expanders.
Na, unsere Erfahrungen sind, dass ein Expander eben auch sehr energieintensiv ist. Ich glaube, das ist nichts Neues. Und wir ihn deshalb ganz gezielt für speziellen Einsatz der Monokomponenten einsetzen. Das heißt, wir behandeln Monokomponenten dort mit und nicht das Mischfutter. Weil ich bei einer Monokomponente halt den Prozess explizit auf diese Komponente ausrichten kann. Was Temperatur angeht, was Druck angeht. Ja, das kann ich halt rausarbeiten für eine Komponente. Selbst wenn die Komponente schwankt, kann ich einen Prozess rausarbeiten, der sehr stabil ist. Was ich hingegen, wenn ich ein Mischfutter auf einem Expander behandle, eher schwieriger ist. Wenn ich dort einen Getreideaufschluss hinkriegen möchte, weil ich Getreide drin habe in der Mischung, dann wird das immer schwieriger, diesen wirklich präzise abzustimmen, auf den Wert zu arbeiten. Deshalb arbeiten wir auf Monokomponenten, die wir dann später wieder in einem Mischfutter einsetzen.
Wie sehen Sie die Konditionierung in der Zukunft?
Na, ich denke, man muss sich die Frage stellen, ob die Konditionierung, sprich Pelletierung, Granulierung, die Zukunft ist oder ob man diesen Prozess, der natürlich Vorteile bringt, keine Frage, aber ob diese Vorteile nicht auch durch einen Prozess zu bekommen sind, herzustellen sind, der deutlich energieärmer ist. Energiekosten werden immer teurer, auch gesellschaftlich ein großer Energieverbraucher zu sein, steht man nicht besonders gut da. Und ich glaube, da muss man sich Gedanken machen, wie man diesen Prozess energieärmer gestalten kann. Das ist, glaube ich, eine ganz große Herausforderung. Und ja, dazu würde ich gerne einladen, dass die Leute sich daran beteiligen, sich Gedanken zu machen, wie kann man auf diesen Prozess verzichten oder ihn deutlich energieärmer gestalten.
Eine sehr relevante Frage. Die Antwort ist möglicherweise nicht einfach zu geben. Was sind Ihre ersten Gedanken?
Ja, ich denke, also man muss sich ja seinen Prozess angucken und schauen, was ist an meinem Prozess notwendig, damit ich dem Tier ein gutes Material zur Verfügung stelle. Und ich denke, ums Zerkleinern werden wir nicht drum herum kommen. Weil wir müssen das Getreide, wir müssen die Ölschote, wir müssen das entsprechend darlegen, damit es im Tier funktionieren kann. Sprich, wir eine gewisse Oberfläche schaffen, eine vergrößerte Oberfläche schaffen, damit das Tier an die Inhaltsstoffe kommt. Aber das Pelletieren, ja, wir machen das heute häufig, wir wollen gerne hygienisieren, wir wollen gerne kompaktieren, wir wollen gerne, dass das Tier nicht selektieren kann. Das sind alles so Sachen, die wir heute machen, um das dem Tier vorzulegen. Das ist ja die Frage, brauche ich das wirklich? Oder reicht eine Zerkleinerung und vielleicht ein Schritt, wie der auch aussehen mag, ein nächster Schritt, der deutlich energieärmer ist, wo ich es auch schaffe, das Material zu hygienisieren, weil ich denke, das wird in der heutigen Zeit immer ein Thema bleiben, ja, ein hygienisch einwandfreies Material zu bringen. Aber muss ich wirklich dieses Kompaktieren, was einfach das Kompaktieren durch Presskanäle verbraucht so viel Energie, weil es einfach so viel mechanischen Widerstand liefert, brauche ich so viel Energie und da muss man sich halt Gedanken zu machen, wie kann ich das besser machen. Man muss sich fragen, warum funktionieren 50% als Mehl und warum 50% als Pellet? Und was kann ich bei den Pellets vielleicht an Futtern noch Richtung Mehl bringen? Oder vielleicht einen anderen Prozess. Es gibt ja verschiedenste Ansätze, glaube ich. Es gibt genug kluge Menschen, vielleicht fällt einem was ein.
Once again, many thanks to Mr. Rowold for that fascinating insight and some interesting feed for thought at the end. We have several topics to dig into. Now let's start with steam. Where have I heard that phrase before? Frank Dielersen, CEO of IVS. It's great that you could join us today for this episode. What do you think?
It's always very interesting for us to see how our own customers view steam. For Mr. Rowold, steam is so fundamental that it's treated like another raw material.
Which of course it is. I mean, as you said in our previous episode, it's impossible to get an optimum pellet with poor quality steam. And you end up with pellets that are too wet or not properly hygienized. And that causes bottlenecks and breakdowns in production.
But not only that, poor moisture management leads to inconsistent, non-uniform pellets with a poor pellet durability index. And this is no good for anyone. Steam affects the quality and quantity of every part of the conditioning process. You need a steam dosing unit that can consistently deliver overheated dry steam and penetrate the heart of the feed particles in the conditioner.
Now, I was intrigued by Herr Rowold's comments about energy efficiency and that the fact that the industry needs to become more sustainable. Any thoughts?
He's right. The pelleting process accounts for about 60% of all the energy consumed in the feed mill.
Wow, that's a lot.
Well, we're doing what we can to reduce this, of course.
In what way?
Our steam dosing unit has proven to reduce energy consumption by up to 20%, and that's a significant amount.
Well, that's great, but can you tell a bit more?
The high temperature of our steam dosing unit, it enables better conditioning, which of course reduces resistance in the die of the pelletizer, and it enables a more energy efficient production.
Ronald, does PTN have any new developments in this area?
Yes, we do. Our monoroll pellet mill has been tested for several years and is currently in production. It is based on a unique design that can save up to 30% energy.
So for the feed milling industry, this might be an interesting answer to reduce energy consumption.
Yes, because energy efficiency often equals cost efficiency. The monoroll pellet mill has the potential to save more than 30,000 euros per year.
Okay, so you have some great energy efficient products, but Mr. Rowold is talking about change the entire way we produce feed.
Yes, this is a challenge for the whole industry to pick up. We need to work on it more, and we are.
Can you give us an example?
Well, we are an innovation company with a long established and dedicated expert center. And I can tell you right now that we are working with research partners on technology that could be mind-blowing in its energy efficiency for the animal feed and pet food.
Which brings us very nicely to our final segment of this show. Let's take a brief look at some of this interesting research that you're doing with the industry on conditioning. Tell me about the work that's going on.
There is some very good research being done to improve our understanding of what happens inside the different conditioning systems and how to measure it.
I understand that you work with several third parties on bespoke R&D projects where customers can run tests on their formulations under lab conditions. Is that correct?
Yes, at the Triot Group we work with the Feed Design Lab, the IFF, Wageningen University and Zetadec. Through these relationships we can organize small and medium-scale tests together with customers.
And what exactly is the value of this to these customers?
The value is that customers can test drive different conditioning setups and parameters under lab conditions with no risk of contamination or interfering with their daily production.
And of course I imagine that you have experts on hand who can give a more analytic and data-driven view on the conditioning process.
Exactly, Lars. The more that customers understand about the product they produce and the technology involved, the more they are able to improve.
Right. Thank you, Robert and Ronald, for sharing your thoughts with us here today. And for those of you who would like to know more about the research being done in this field, along with a summary of the topics covered in this episode of Feed Forward, please download our guide to Great Conditioning Digest, and it's available on the Triot website. Thanks, of course, also to Frank Dielessen and Mr. Philip Rowold of Agravis for sharing their valuable insights. If you have any further questions, it's not too late to send them via the chat, which will remain open for a short while longer. Or contact us via the social media channels and we'll get back to you. That's it for this episode. Thank you for watching and we wish you a good summer. Stay safe and keep looking forward. So, gents.
Okay, yeah, that's great.
And that just about wraps up our guide to great conditioning. If you have any questions on this topic, remember that our live chat will remain open for a little while, or you can contact us via the usual social media channels. So please, get in touch and we will get back to you. You can also download a concise written digest of this episode from the Triot website, where you'll also be able to watch episode 1 of this conditioning special, called It All Starts With Steam, which also comes with a written digest. Finally, thank you for joining us, and we hope to see you all again later in the year for the next episode of Feed Forward.